We're looking at piecewise functions here. Now, a lot of functions you might see are linear or just one. So you might see something like that as a function, or maybe even you see something like a quadratic or an exponential function that looks like this, where one function covers all. So this might be something like simply fx equals 2x, and this might be something like, let's make it fx equals x squared plus 3, and x is greater than or equal to 0. So these are not piecewise because these just involve one function. So what is a piecewise function? It's one such as this, where we break the function into two parts and we give a suggested x value through that function. So these sorts of things, if I want to work out f2, then I would have to go look at the first part here and say that that f2 is 2 times 2, which is 4, take away 1, which is 3. But if I wanted to work out f5, I'd have to go to the second part because x is greater than 3, so this gives me 13. Now, what does this thing here mean? 0 otherwise. It just means that the function doesn't exist if x is less than 0. That's quite a simple one. We might see something a bit more like this as a piecewise function. Now, this is actually modeled on kind of real-life data, and this is about Egyptian electricity charges, where they subsidize the charges up to the first 100 units. So if you use 50 units, you'll be 50 times 0.3 piastres for your electricity charge. If you were to, say, use 200, you'd have to put it into this function here. So f200, we'd have to put it into the second function, which is 140 minus 40 is 100 in your electricity charge. And we can also see this on the graph. You can see how the graph is made up. Well, the graph is made up of 3 different linear parts to the model. So this is simply a piecewise function where we make it up of 3 different parts.